Now we discuss example 2.4. Four charges are arranged at the corners of a square ABCD of side D as shown in figure. Find the work required to put together this arrangement. Also find if the charge Q0 is brought to the center E of the square, the four charges being held fixed at its corners, how much extra work is needed for this? So first question is to find the total work done in assembling the charges. That means the four charges, not that fifth one. Okay, find the work required to put together this arrangement. That means ABCD. So we are not considering this charge at the center first. Consider only these four charges. Total work done means what? As I said earlier, we are asked to find the potential energy. How will you get the potential energy? So first you find the total number of pairs possible. Since 4 charges are present, we have already discussed there are 6 pairs possible. Then accordingly you write to the equation. So U is equal to what? 1 by 4 pi epsilon 0. Okay. So take each pair and its distance. So it's given that it is a square. So side length is given as D. Side length is D. So what will be the diagonal length? It is root 2 into D. So you know if the side of a square is A, the diagonal length will be root 2 into A. So now you can write. So first this pair plus q into minus q, it is minus q square divided by, the separation is D. So first term is over. Next, this pair, again it comes minus. So minus q square divided by, separation is D. Then again third pair plus q into minus q, again minus q square by D. Fourth pair also plus into minus, so minus q square by D. Now fifth pair diagonal wise, so plus q into plus q, it is positive, so plus q square, the separation is what? Root 2D. Separation is root 2D plus, now next sixth pair minus q into minus q, that also is plus q square divided by that separation root 2D. So 6 terms we have written. Is it not easy? Yes. Now club the terms and simplify. So 1 by 4 pi epsilon 0 into minus 4 terms are there, no? So 4 q square by D minus 4 q square by D plus, here there are 2 terms. So 2 into q square by root 2D. Now again common terms I am taking outside. So 1 by 4 pi epsilon 0 into, okay, minus 4 plus 2 by root 2 into, what is that term? Q square by D. Q square by D I wrote outside. So minus 4 plus 2 by root 2. What is 2 by root 2? It is root 2. So our expression becomes 1 by 4 pi okay, 1 by 4 pi epsilon 0 into, so hope it is clear. So it becomes 1 by 4 pi epsilon 0 into q square by D into minus 4 plus root 2. 2 by root 2 is root 2. So this is the answer. So this is what is asked. So you can keep as such, because nothing is means no other values are given, no. So keep it as such. So here now the next question is at the point. So again we will go to the reference diagram. So at the point E, okay, charge Q0 is to be kept. At the point E, charge Q0 is to be kept. What is the work done, or how much extra work is to be done to do this. So 4 charges we have already brought. Now this is the work done. That means the expression which we derived. Now what is the work done to bring the extra charge Q0 at E? So how will you find the work done in bringing Q0 to the point E? What is the expression? Charge into potential at that point. So what is it? Work done, extra work done, suppose we call it as W5, that is equal to Q0, that is the charge to be brought, and it is brought to the point E. So Q0 into VE, where VE is the potential at the point E. Okay, so first step is to find VE. So how will we get to VE? Which all charges produce potential at E? Charge at A, B, C and D. Charges at A, B, C and D produce the potential at V. So one by one you have to find the potential at E. So before that, let's discuss what about the distance of the points A, B, C and D from E. So from this diagram, all these points A, B, C and D are at equal distance from E. What is that distance? Half the length of the diagonal. Length of the diagonal is root 2D. Half the length means what? Root 2D by 2. So that is equal to D by root 2. Okay. So this distance is what? D by root 2. So from the point E to the distance to A, B, C and D are same, and that is D by root 2. Now let's find that work done. So work done is equal to, so potential due to the charge at A, potential due to charge at B, potential due to charge at C and that at D. All these potentials you have to add. So first at A you have positive charge. Okay. So 1 by 4 pi epsilon 0 Q divided by that distance is D by root 2. That is the potential due to the charge at A. Next at B you have negative charge. So potential will be negative. So minus 1 by 4 pi epsilon 0 Q divided by D by root 2. Next at C you have again positive charge. So it is plus 1 by 4 pi epsilon 0 Q divided by D by root 2. Next, at D you have negative charge. So it is minus 1 by 4 pi epsilon 0 Q divided by D by root 2. So adjacent terms, they get cancelled? No. All the terms get cancelled. So the net potential at E is equal to 0. So what is the work done in bringing that fifth charge? Q0 into 0, that is equal to 0. There is no need of doing any work in bringing that fifth charge. That is the assumption.